In this video, I'm going to go over clipping, including what it is, what causes it, where it came from, why people say it's bad, and why it isn't always bad. I'm also going to upload a part 2 focusing on the math behind clipping and Fourier transformations and how they relate to and help us gain a deeper understanding of clipping, and also how they can be used as a really powerful sound design tool in synths like Serum, Phaseplant, and Vital. Fair warning though, that video is going to be very technical and mathy, and this video is going to be pretty numberless and theoretical. So there should be no math in this video except for a 1. So brace yourself, there's going to be a number 1 later. Other than that, you're good on the numbers, okay? If you don't want to bother with the technical bits, you can just watch this and fully understand. Clipping is a type of distortion that happens when an audio signal is too loud or too big for the system that's trying to represent it. So a sound can be too loud for a microphone and it can't pick up sounds that loud. An electrical signal that's supposed to come out of an amplifier can be larger than the amount of power that the amplifier can actually put out. Or a speaker's cone travel can actually be not as wide as how far the amplifier is trying to push it. So those can all cause clipping. And the easiest way that I find to understand clipping is to picture it as the sound wave within barriers. So we've got an upper and lower bound for the sound wave. So in this diagram, I'm not an animator, in this diagram we have 2 bars and a wave between them, and the bars represent the maximum amplitude that the system can produce. So let's say that the amplifier can only push plus or minus, okay, get ready for it. There's a number coming. Right, you ready? The amplifier can push plus or minus 1, okay? 1 volt. You did it. Oh, this isn't supposed to be this hard. Hey! We did it! We got through the number. Okay. The amplifier can only push plus or minus 1 volt. And as you can see here, the sound wave is well between the minimum and maximum that the amplifier can actually handle. But if I turn up the signal, the sound wave is higher than the maximum that the amplifier can generate. So in this case, what happens is the wave gets cut off or pressed up against the ceiling, and as the amplifier can't create 1.2 volts or whatever, it just creates 1 until it's asked to do less than 1 again. And then it's back on the actual line that it's supposed to represent until it reaches the floor, where it goes below the lowest, and it can't represent that low either, so it just presses along the bottom. So instead of ending up with this kind of signal, your signal ends up coming out looking like this. This is called clipping because the peaks and the troughs of the waves are clipped off at the maximum ranges. Let's jump into Ableton and I can show you what this looks and sounds like. This is an F sharp with no clipping. As you can see, it's just the clean sine wave that we were working with from before, and it looks just like a sine wave. We're going to clip this a little bit now and then take a look at what it looks like. So if we bring the gain up and we're just running it into a limiter over here, with just a little bit of clipping, we now have the following. Not only could we see on the spectrum all of those peaks, looking at this now, it doesn't look quite like a sine wave. It's mostly like a sine wave, but it starts to curve a little sharper here than you would expect. So let's clip it even further. Again, more harmonics in here that you can see, more peaks. And this is definitely not a sine wave. Just looking at that, you can tell, oh, there's corners in it. So now I'm just going to let this play for a moment. We're going to look at the waveform, and I'm just going to clip it more and more. Okay, we clearly reached a point where there was an absolute mess there. So here we can see the sine wave getting sharper and sharper as I turn up the knobs. This is an artifact of the limiter, so don't worry too much about that. And then we reach this point here. The wave starts folding back on itself and becoming much closer to what we know as a square wave, and then kind of looks like a sine wave again with this little fold back in the middle, and then really big squares. And this is more analogous to the drawing that I was showing you earlier. Obviously, we have to fight through a lot to get there because the system's trying to save us from doing this accidentally. But look at that. It's absolutely sharp. I will get more into why clipping changes the sound like this and what is causing it to do that in the second part of this video. But one thing I do want to note is that when you clip the audio and it has multiple frequencies in it, you can actually lose out on some of those high frequencies. So I've got a bass loop here, which I'll play, and we'll do the same thing. We will watch the recording, but I will also slowly clip it as the loop plays. So same issue. You can see we start out with a solid amount of information. You can actually hear the high end and the bass at the same time here. But then as we start clipping it more, the bass starts pushing out some of the high end. And you get less and less high end on each bass shot. And as it gets thicker and thicker, these signs turn into closer and closer to squares. And then by the end here, you're getting all vertical lines. You don't get any curve whatsoever in here. I mean, look at that. This is called ringing out. That's another artifact that I'm going to talk about in the second half of the video, so don't worry too much about what's going on there. What's important to understand is that all of these dots, all of the samples that's being measured, are just obliterated against the ceiling. So if you have in your bass loop these little nuances and these little ups and downs that represent the high frequencies, those are delicate. And if you clip something, especially something that has bass in it, they're all going to get shoved up against the ceiling, and you're going to lose all of this nuance. Fortunately, since clipping is usually a physical limitation of equipment, we can actually get around it quite easily in the digital world. You don't have to build a whole robust system into a computer to handle bigger values. You just give the computer more space to calculate the height of the wave, and then it has more room to hold bigger waves. So for every single digit, that's a 1 or a 0, that you add to the wave position marker, you've actually doubled the amount of values it can hold. And so because of this, it's very easy to double and double and double and double and create massively larger amounts of space to hold these large waves on signals that would normally clip in physical systems. So on major DAWs, you can actually clip insanely high on a lot of channels, as long as you bring it back to 0 before it leaves the master channel. The master channel is the only one that will actually clip at 0. Allegedly, Ableton clips somewhere around 62 decibels above per channel. So if you have every channel running at plus 60 going to the master, and then you just turn it down a ton in the master, you actually won't clip the audio at all. So far, we've primarily been talking about hard clipping, which is the most basic type of clipping. There are actually a few other types. The most common is soft clipping, where instead of sharp corners at those boundaries, the signal is actually compressed a bit more earlier as it approaches the range, and so it creates more of a smooth, rounded-off corner instead of a sharp edge at the borders. And because this is more gradual, and because soft clipping creates mostly even harmonics instead of odd harmonics, which I'll explain more in the second part of the video, it can sound more natural, and therefore it'll let you turn up a sound and clip it a lot more before it sounds distorted or clippy, as opposed to hard clipping, which will sound clippy a lot sooner. You will hear from a lot of people that clipping is very bad and that you should avoid it, and that is true. You should avoid clipping. As you heard earlier, clipping can massively distort and insert harmonics to your sounds and make it sound a lot messier, and enough clipping can actually damage speakers and amplifiers, although to be fair, pretty much everything professional nowadays has built-in protection, so if it starts clipping too much to the point where it might damage itself, it'll just turn itself off, but still, you don't want that to happen either. So clipping is something to avoid. Watch out for it. You will also hear that clipping is good from quite a few people and that you should do it, and this is also true. You should definitely be using clipping. As we heard earlier, clipping alters the sound you've created and makes it messier and inserts harmonics that don't belong there. Sometimes that's what you want. Just like everything else that you learn in music, clipping is a tool in your tool belt, and instead of being afraid of it or avoiding it, you should learn what it does, how it sounds, and then when you want to use it to make the music that you want to make. For example, in acoustic music, clipping is very rarely used because usually the idea is to capture the sound that the instrument would make if you were listening to it in person. Whereas in heavy bass genres, clipping is almost an essential part of the sound design process that a lot of people use, and a lot of the biggest artists clip an insane amount that most of us would never even think about doing because they understand how to control clipping and how to make it sound like they want it to. So don't let anyone tell you that clipping is good or clipping is bad. Understand that clipping is a tool that you can use to your advantage to enhance what you're currently creating. That being said, it is generally frowned upon to have your master channel clipping by a lot. It can kind of mask the sound you created by a mess of harmonics, as we sort of heard earlier. But again, some people do it, so if they can do it well, then you can learn to do it as well. Well, I think that's plenty to understand about clipping for now, don't you? If you want to know more about the math behind why clipping sounds like that, how to tell what a wave might sound like just by looking at it, or what climate change and a dead French guy have to do with audio engineering, go watch part 2 up there. But if not, you know pretty much everything you need to know to start using the information about clipping anyways. As always, thank you so much for sticking around to hear me ramble, and if you have any other topics that you want me to cover, let me know by any means.